In this lecture, I will describe the psychrometric chart and its application in different air conditioning processes. So, this is the psychrometric chart. This axis will represent dry bulb temperature. That means, if you proceed from left hand side to right hand side, then the dry bulb temperature will increase, and this green line, vertical green line, will represent or is representing the constant dry bulb temperature line, and this axis will represent the W, that is specific humidity. That means, if you proceed from this point to this point, the W is going to increasing. This red line will represent the constant phi. That means, phi is equal to constant. That means, relative humidity is equal to constant, and this particularly this red line is 100% phi. So, we can say this red line is constant phi, and this inclined skyline is representing the constant enthalpy H as well as wet valve temperature is constant, this line, and H we can get from this scale in kilojoule per kg of dry air, and dry bulb temperature in degree Celsius. And this inclined blue line is representing specific volume of the water vapor per unit of dry air, and this line is representing the pressure. Now, let us start with a simple example. If this is a TS diagram, and this is a constant pressure line, and if you consider this is the initial state 1 of the mixture, where water vapor is superheated and mixture is unsaturated. If at constant pressure the temperature is going to decreasing, and after a certain point it will reach here, that means, by that amount of water vapor, due to the temperature drop, the mixture becomes saturated, and at that point the water vapor starting condensation and dew will form. So, that is why this point is called dew point. Clear? This process can, suppose this is the 2 process, so on to 2 process. This process can represent here. If we consider this is the point 1, and at constant pressure and W remains constant, only water vapor present in the mixture also constant. So, only temperature will decrease. So, if you consider this line, will the temperature decrease, and that is why this here there will be the point. So, at constant pressure, so this is the point 2. Due to the temperature drop at constant pressure, so P is constant. Due to the temperature drop, the mixture becomes saturated by the same amount of water vapor present in the mixture. So, this point is, you can say, dew point with respect to this point at constant pressure as and W for that particular case. Now, application of the psychrometric chart. As we know that the air conditioning process not only about the temperature drop of the room, but also we have to consider the human comfort, which is a function of humidity of the air. Let us start. First of all, sensible cooling and sensible heating. What is sensible cooling and what is sensible heating? What is sensible cooling and what is sensible heating? That is nothing but the air. If you consider the sensible cooling, the air is cooled down, air is cooling down due to it passing around the cooling coil. Sensible cooling, that means if you consider this is the initial state, suppose this is the initial state of the room air. So, we can say this is T dry valve temperature 1, and suppose this is the cooling coil temperature, suppose this is 3, cooling coil temperature 3. So, this is T dry valve temperature 3, clear. So, when the room air is passing around the cooling coil, the temperature of the room air will decrease. Suppose the room air is proceeding towards the cooling coil temperature and that will stop here. So, this is the final temperature, suppose 2, final temperature of the room air. So, this is T dry valve temperature 2, clear. And so, room air will cool down from temperature T dry valve temperature 1 to T dry valve temperature 2, due to what? Due to this cooling coil. And from that incident, a very interesting and very important term will come, that is what? Bypass factor of the cooling coil. So, what is bypass factor? So, bypass factor is, bypass factor. What is bypass factor? Bypass factor is nothing but the ratio of temperature difference between the final air temperature and cooling coil, and temperature difference between the, so this here is here, this is cool down, temperature is going to decreasing, is that clear? So, temperature difference, bypass factor is what? Temperature difference between the final air and cooling coil to the temperature difference between the initial air temperature, initial air and cooling coil. So, we can write T T dry valve temperature 2 minus T dry valve temperature 3 divided by T dry valve temperature 1 minus T dry valve temperature 3. That means final temperature difference divided by initial temperature difference. And there is a very intrinsic relation between efficiency of the cooling coil and bypass factor, which is nothing but efficiency of the cooling coil is nothing but 1 minus bypass factor. That will be very easy to understand. If you put the value of bypass factor here, you can easily understand this is nothing but what is the effect and due to what we have to invest how much amount of energy. That is the efficiency, we know that. Now, similarly, what is the sensible heating? That means there will be a heating coil around which room air will passing, and that is why the temperature of the room air will increasing. So, that is called sensible heating. So, if you consider this is sorry, if you consider this is the initial point of the room. So, this is T dry bulb temperature 1, suppose this is 1, and this is the suppose heating coil temperature 3, suppose this is the 3 point. So, when the room air will passing around the cooling coil, then what happened? The temperature of the air will increase and it will proceed towards the, sorry, this point will be here, towards the 3, and suppose here the final temperature of the room air or final condition of the room air. So, this is what? This is T dry bulb temperature 2, suppose this is 2, and this process, and what will be? This process is called sensible heating. What is the bypass factor for that particular case? So, bypass factor is what? Bypass factor will be nothing but final temperature difference between the room air and cooling coil, heating coil, that will be T dry bulb. So, this is the T dry bulb temperature 3, T dry bulb temperature 3 minus T dry bulb temperature 2 divided by T dry bulb temperature 3 minus T dry bulb temperature 1. So, T dry bulb temperature 3 minus T dry bulb temperature 2 divided by T dry bulb temperature 3 minus T dry bulb temperature 1, that is the bypass factor of the sensible heating. So, similarly, we can get the efficiency of the heating coil 1 minus bypass factor, and how much amount of heat we have to rejecting or we have to absorb from the system for having that effect, we can easily find out from how can, suppose this is H1 and suppose this is H2. So, definitely we can get this value mass flow rate of air into H1 minus H2. Clear? That is nothing but what? That is nothing but Cp of air into temperature here minus here. That means mass flow rate of air into T dry bulb temperature 1 minus T dry bulb temperature 2. So, mCpa T dry bulb temperature 1 minus T dry bulb temperature 2, that is equal to mass flow rate of air into H1 minus H2. So, that is the amount of energy we have to rejecting for having this sensible cooling case. Similarly, we can get this. Now, humidification process. What is the humidification process? We will consider here at constant dry bulb temperature humidification process and dehumidification process. So, what will be the humidification process? Suppose this is the initial point 1. So, this is W1, and if we humidified the air, the W becomes in W will increasing. Suppose this is 2, suppose this is 2 process. So, this is W2. So, this 1 to 2 process is humidification process as at constant dry bulb temperature, at constant dry bulb temperature. Clear? That means, at constant temperature we just increasing the amount of water vapor in the mixture, and that is why the W will increase. So, how much energy we have to invest for having that effect? Similarly, we can get. So, this is H1, this is H2, we can get this. Now, dehumidification process, the reverse process of that. If you consider this is the initial point, and at constant dry bulb temperature, if the W becomes minimum, that means W is going to decreasing. So, we can say this is the W2 2 point, this is the W1. So, at constant temperature, dry bulb temperature, this 1 to 2 process is what? Dehumidification process. So, how much dehumidification is happening? For that case, W1 minus W2, also W1 minus W2, clear. So, how much energy we have to invest or we have to subtract from the system? Easily we can calculate by help of H, clear. So, this is the humidification and dehumidification process. Now, next sorry, next is what? Next is cooling and dehumidification process. What is cooling and dehumidification process? Cooling and dehumidification process is nothing but we have to execute two processes simultaneously, cooling as well as dehumidification. Suppose this is the point, initial state of the room air, initial state of the room, this is 1, suppose 1. So, this is W1 and this is suppose T dry bulb temperature 1, and suppose this is phi 1, sorry phi 1, clear, and suppose final state of the room is here, suppose here. So, suppose this is 2 point. So, here this is the W2, this is the dry bulb temperature 2, and suppose this is phi 2. So, this process is nothing but cooling and dehumidification. That means, temperature is going to decreasing as well as phi as well as W is going to decreasing. So, we can say this process, sorry, this process is nothing but cooling and dehumidification. This process is involved with two types of process. What? First of all, if you consider 1 to 2 process is combination of 1 to, suppose if you consider this is I for intermediate, 1 to I and then I to 2. That means, 1 to I is pure humidification process and I to 2 is sensible cooling process. So, two types of energy transfer will be there from here. If you consider Hi, from here if you consider this is H sorry H1, if you consider this is H2, then this part is what? Latent heat. So, del H latent heat, due to, because from here to here some water vapor will rejecting from the mixture, and that is why at constant dry bulb temperature the W becomes minimum. That means, W is going to decreasing, and from I to 2, that is sensible cooling process. So, from here to here, so that is del H sensible cooling. Now, from that expression, interesting parameter, that is what? That is what? Sensible cooling factor or sensible heating factor. So, sensible cooling factor is what? Sensible cooling factors, sensible cooling factor, that is nothing but what? Del H, sensible cooling divided by del H total. That means we can write mass flow rate of air into Hi minus H2 divided by mass flow rate of air into H1 minus H2. So, that is the sensible cooling factor. Clear? Similarly, we can explain the heating and humidification. That means, if we consider this is the initial state of the room air, suppose this is the T dry bulb temperature 1, suppose this is the 1 point and this is W1 and suppose this is phi 1 and suppose this is the final state of the room air, suppose this is 2. So, here W2, here dry bulb temperature 2, clear and here the phi 2. So, this process we can say this process 1 to 2 process is nothing but a heating and humidification. That means, temperature is going to increasing as well as the humidification going to increase, humidity going to increasing, because we can see W2 is greater than W1 easily. The same explanation will be there for that case. So, similarly, this is the intermediate point. So, similarly, we can calculate the energy at different state and sensible for that case heating factor H2, clear. So, this is the heating and humidification process. Heating and humidification, that means dry bulb temperature is going to increasing as well as what? The W going to increasing. So, heating and humidification process. Now, next, cooling and humidification. What is cooling and humidification process? That means, at the same time cooling will be there as well as humidification will be there. So, cooling and humidification, that means, if you consider this is the initial point, suppose this is the initial point 1. So, this is dry bulb temperature 1, this is W1 and suppose this is the final point 2, final point 2 suppose. Okay. So, this is W2 and this is T dry bulb temperature 2. So, if this process will be just like that, if process will be just like that from here to here, we can say the cooling process, that means dry bulb temperature going to decreasing as well as humidification is going to happening. So, temperature, dry bulb temperature going to decreasing, humidification is happening, that means W is going to increasing. So, this process 1 to 2 process is called cooling and humidification process and we can calculate. So, this process humidification process, clear. And similarly, we can explain the heating and dehumidification process. Suppose this is the initial state 1. So, this is dry bulb, T dry bulb temperature 1. Suppose this is the temperature point state 2. So, this is W2, this is temperature dry valve temperature 2. So, this is definitely W1, this is W2, this is W1. So, we can say this 1 to 2 process, this 1 to 2 process, 1 to 2 process is what? Heating and dehumidification. You can see the temperature of at initial state was TVT1, T dry valve TDVT1 and final state temperature TDVT2, which is definitely greater than. So, this is heating process and the W1 is greater than that of W2. So, this is dehumidification process. So, this is heating and dehumidification process. So, these are the basic process involved in air conditioning, which is related with the psychrometric chart. So, I hope this lecture will help you to understand the different process involved in the air conditioning process and how we can calculate the energy for that for a particular case. Thank you.